All right, we're going to review subtraction, and our main emphasis today is talking about how you can subtract if it seems like the number that you're subtracting from or the amount that you're subtracting from seems less than what you're subtracting. And sometimes it can look that way, especially since you know you have to line up the decimals first, but you may have to place some zeros in the number itself after the decimal to help you do the subtraction. So we're going to follow these basic steps each time. We will always line up the decimals, meaning as you line up your problem, 10 and 6/10, and then minus 1 and 75/100. So you're subtracting 1 and 75/100 from the 10 and 6/10. That decimal alignment is very important. And you can see that there. And then if you have a hole, an open space, you can add a trailing zero. That's referring to this zero right here. It wasn't in the original problem. However, since you had to subtract 5 from that 100th place value, you would need to have something there. And then it says subtract and drop the decimal down. Here's another example. If you start off with 3 and 8/10 minus 1 and 26/100. Now if you line up your decimals again, placing them right over each other to do your subtraction, you'll notice that there's a missing spot. This spot was open because there's nothing following the 8. So that's called a trailing zero, or a zero that you can place in the hundreds place, or the thousands, or the 10,000s if you need it. And then from there, you can go ahead and you can do your subtraction. So you can trade in from the 8, say, hey, give up 1, make 10 hundredths, and then change that 8 to a 7 since there's only 7/10. Okay, so let's give it a try. You can watch as I go, and then when, of course, in any ed puzzle, when it pauses and asks you a question, you need to complete your answer. So we're going to start by lining up our decimals. Now, when your decimal question, especially in subtraction, is written in this form, which is a horizontal form, it is much, much easier to change it to vertical form. That way, lining up your decimals, paying close attention to the places, can be done pretty easily. All right, so as I line up those decimals, I notice that it looks like this 5 here needs to be subtracted, but there's nothing to subtract this 5 from. So we're going to go ahead and place a 0 in this spot, because there was no value in the hundredths place, and it doesn't actually change it at all. So I can't subtract 5 from 0. So 0 goes next door, asks for some extra, becomes a 10. 10 minus 5 gives you 5. 5 minus 0 gives you 5. And the 6 hasn't changed at all. It stayed the same. So 6 minus 0 gives you 6. 6 and 55/100. Okay, same again. Let's line up our decimals. 12. My decimal is right here. Even though it's not visible, I know that that always means it's at the end of the number. And if I'm lining up the decimals, the 1 would go under the 2 from the 12 and the 3 in the 10th place. It's a subtraction problem. Place my 0. So I have something to subtract from the 3. And then from there, I'm going to say I can't subtract this 3 from 0, so I have to borrow, trade in, and make this a 10. Okay, go ahead and subtract and solve. Okay, 10 minus 3 is 7. Decimal, still lined up. 1 minus 1 is 0, and then you have 1 of the 10. 10 and 7/10. Next problem. Okay, let's line up our decimals. So again, 17 as a whole number. So 17 decimal. And then I have this next number, 0 ones, 0 tenths, 1 hundredths, and 9 thousandths. Subtract. I need some trailing zeros here. So fill in your zeros and solve. All right, I'm going to fill in the zeros, which you also did. And then I'm going to go ahead and solve. Now it looks like I have to subtract this 9, but there's nothing here to subtract the 9 from. And there's nothing next door. Nothing to the next door again. The first place that I get any value that I can trade in, and get some value from is the 7. So I'll take away 1, So I take away 1. This one needs to become a 10. This is a 9, and this is a 9. The reason is, if we gave this one back from the 10, then this would bump this 9 up, this would bump this 9 up, and this would become that 7 again if we gave it back. But we're using it up here in the thousands place. So 10 minus 9 is 1. 9 minus 1 is 8. 9 minus 0 is 9. 6 minus 0 is 6. And 1. 16 and 981 thousandths. Okay, we're moving on to a context question, a story problem, something that is in context. So Jeffrey Mutai from Kenya set the record for the New York City Marathon in the year 2011. His time was 2 hours, 5 and 1/10 minutes. In the year 2013, he won the marathon again. This time, his time was 2 hours, 8 and 40 minutes. How much faster was his time in 2011 than 2013? Now you might say, what, faster? He had less in 2011, but remember, if you're running a marathon or any kind of race, you want to have less time. That actually makes you faster. So if I want to know how much faster, this is also finding the difference, and I know difference is subtraction. So if I subtract, I'm going to start with my larger number, so the 2 hours, and then I have the 2 hours and the 2 hours are going to end up working out pretty much the same. But I have 8 in the minutes and 4/10 of a minute. And then I'm going to subtract the 2 hours, 5 in the minutes, and 1/10. Let's see, well, if we subtract the tenths, we'd have a 3 and 3, and then these are 0 hours. So we have 3 and 3/10 just in minutes. In the Olympics, 1908 Olympics, Eric Lemming from Sweden won the javelin throw. He threw the javelin 54 and 82 meters. He won again in the year 1912, 4 years later, with a throw of 60 and 64 meters. How much longer was his throw in 1912 than it was in 1908? Go ahead and solve. This is a type of problem that you cannot use your calculator, but a piece of paper to line up your decimals would be very helpful. So you may use paper pencil. Go ahead and solve. So if I start off with his value of 60 and 64 hundredths, to find the difference, I'd subtract his initial throw, which was just a little bit shorter. 4 subtract 2 is 2 in the hundredths. 8 subtracted from a 6, not enough. So I could go next door to the ones place, but they don't have any, so I have to go again. Ask a 10 to give up 1. That would give this set a 9, and this would become the 10. So 16 minus 8 brings it down to an 8. 9 minus 4 says there are 5 ones, which leaves you with 0 tens, and it looks like the label was javelin throw, measured in meters. And in 1984 in the Olympics, Greg Louganis won the gold medal in the men's springboard diving. To calculate the diver's final score, the average from all 11 dives are added. The average scores of 11 dives are added together. What was his final score? You're going to need to add all of these scores together. So go ahead and start adding to get your grand total. No calculator. This one took me a really long time adding each of them up. I chose to add them up by putting 3 of them together at a time and then adding, finding the sum, 3 more, and then adding 3 more, adding, and then putting the last 2 together. And after I did, I added them all up to get a grand total of 754 and 41 hundredths. And that completes your Ed puzzle for today. Now you're on to some practice on a class kick.